Okay, so the last reaction tied to reactivity series will be your reduction of metal oxide. Okay, for reduction of metal oxide, you will have to know what are the metal oxide that can be reduced, okay, by reducing agent. The common reducing agent will be carbon or hydrogen. Okay, so the cutoff point is actually at the aluminum part. Sorry, not aluminum, zinc part. Zinc and below, okay, the metal are considered as not so reactive. So these metal oxides will be not so stable. Remember, more reactive metal form more stable compound. Less reactive metal form less stable compound. So zinc and below the metal are less reactive, so the oxide will be less stable. So zinc oxide and below the metals oxide, like iron oxide, lead oxide, all those, the metal oxide can be reduced by carbon. Okay, those metals that's above zinc, like potassium, sodium, calcium, magnesium, aluminum, all those, the metals are considered reactive metal. So the oxides are very stable. So the oxide cannot be reduced by carbon or hydrogen. Okay, so the only way to get these metals will actually be by electrolysis. Okay, electrolysis of the molten compound. Okay, so electrolysis, of course, is very expensive, more expensive. That's why, but no choice for this metal. So those less reactive metal got a choice. That's why we use carbon, which is cheaper. Okay, but there's actually another reducing agent that can be used, which is hydrogen. But hydrogen not so powerful. So only iron and below, okay, only iron and below the metal oxide then can be reduced by hydrogen. Okay, right? So you have to take note, zinc and below in the reactivity series, oxide can be reduced by carbon. Below zinc, iron and below, then the oxide can be reduced by hydrogen. That means can be both hydrogen or carbon. But industrially, technically we use carbon because carbon is cheaper, easier to obtain compared to hydrogen. Okay, because hydrogen you have to use cracking all those process. Okay, then next thing you have to know is if the metal oxide react with carbon or react with hydrogen, what will you get? The idea is very simple. It's reduction, so it's redox. Okay, so the metal oxide, if you react with carbon, you will get metal and carbon dioxide. So the metal oxide actually passed oxygen to the carbon. So the metal oxide will actually be reduced. You learned redox already, so you need to know. So it'll be reduced. Carbon to carbon dioxide is actually oxidized. Okay, because gain oxygen. Iron oxide lose oxygen, so become metal, so it's reduced. Okay, so metal oxide plus carbon, you get metal and carbon dioxide. Okay, the metal oxide is reduced to metal, the carbon is oxidized to carbon dioxide. So the carbon itself is actually acting as a reducing agent. Okay, if you use hydrogen, then similarly, instead of forming carbon dioxide, you form H2O, but the oxygen still also pass to the hydrogen. So metal oxide react with hydrogen, you get metal and water. Okay, so same thing, like iron oxide react with hydrogen, you get iron and H2O. So the metal oxide similarly is also reduced. Okay, the hydrogen is oxidized. Okay, so the hydrogen is actually acting as a reducing agent in this reaction. Okay, that's why it's called reduction of metal oxide. Okay, right.